Good morning, everyone. Welcome to the latest in our cost-effective code compliance series here at the Lighting Design Lab. We are joined today with a wonderful panel of experts in the various parts of the code information that we're going to be discussing today. Duane, can you slide us forward, please? Before we begin, just a short, brief little bit of housekeeping. During the webinar, all of you will be muted. Much as we'd love to chat with each of you, there's just too many people in this format to be able to do that. So when you have questions, and please go ahead and give us questions, use the chat feature in the control panel. You'll submit questions to me. I will go ahead and keep an eye on them and try to either answer them as they come in, or in some cases, we may hold larger questions till a little bit later in the broadcast. So we will pause periodically, but not entirely real time. So you will have a variety of online polls that we'll be submitting to you. We'll ask you to please go ahead and answer those. And there'll be a short survey following the webinar. These really help us to craft what kinds of classes and trainings that would be very helpful for you, the listening audience. So please go ahead and send them out. We will be going ahead and putting a recording of this webinar up on our webpage, along with all of the other recordings that we've done. And if you have questions, please go ahead and reach out to either lightingdesignlab@seattle.gov or to me as well. We are, of course, brought to you today by predominantly Seattle City Light. Right. The Lighting Design Lab is a function of Seattle City Light, and we are really quite blessed to be part of such a forward-thinking utility, both from a ratepayer standpoint as well as being able to bring you classes like this. We are also bringing to you the Seattle Department of Construction and Inspections. It's Duane Jonlin, who is predominantly responsible for really overseeing the updates to the codes that we'll be discussing today. And we'll also be talking to Julie Banerjee and Madeline Kostick from City Light Customer Care and Energy Solutions Division to talk about how the utility can help in some of the programs that we have available. Okay, so without further ado, Duane and I will be bouncing back and forth, but I didn't realize this was going to be here. So quick update, just in case any of you are not familiar with me. Shaun Darragh, Senior Lighting Specialist at the Lighting Design Lab. Been a lighting designer for more than 30 years, lighting designer, educator, sustainability specialist, you name it, whatever. Duane, you want to introduce yourself?
Duane Jonlin. I've been part of Seattle for a long time and spent most of my career as a practicing architect for several years, actually overlapping with Shaun at one firm, and have for most of the last decade been in the position of the energy code advisor at the city. And over there on the right, I just wanted to say that the basic theme of this whole day is going to be, this is not impossible. We can do this. We got it. So, good morning, everybody. and we're here today to talk about how lighting and other electrical issues fit into our drive towards a carbon neutral society. And we've got ambitious laws on the books already, and the legislation is in play to speed things up even more at the local and national level. Washington State has maybe 2% of the national construction market, and Seattle less than half of that, but we do exercise considerable leverage as other progressive states and cities around the country often pick up our ideas and expand on those. They even find the way into the national standards. I should say yesterday was kind of a special day in this whole thing, because yesterday when the state energy code went into effect, and it's also the day when the Seattle City Council voted to enact the Seattle Energy Code, and so we have a little mandatory waiting period before that kicks in. But on March 15th, will be on to the 2018 code in Seattle as well. I've heard lately that every single fixture at Light Fair in Chicago has been LED, and this will certainly be the lighting story for the next decade as well. The DOE projections have always turned out to be too conservative as far as how fast progress happens, but you can see that they're still projecting some excellent growth in efficacy, even as the cost of the components comes down. And it's quite rare for anything in building construction to get both cheaper and better every year. But Shaun, how does this work?
Well, one of the interesting things about lighting, particularly with respect to energy effectiveness and code cycles, has been that really since we began this effort years and years ago, lighting's been the low-hanging fruit, right? It's been relatively easy to go ahead and harvest some pretty significant energy savings. We've done that in several different ways, right? One of them has been, frankly, research individual visual systems. We're no longer lighting offices to 100-foot candles, for example, right? Other parts of that have been improvement in design and systems. We've got better equipment, we've got more efficacious equipment, we've got better control systems. Certainly, as Duane has just mentioned, the biggest part of this has been, frankly, the improvement in light sources, right? We've gone from T12 to T8, from magnetic ballasts to electronic ballasts, from halogen to ceramic metal halide. Now everything is LED, right? And as Duane has suggested, we've seen year over year really huge improvements in both LED quality and the effectiveness of that. So this is terrific, right? At some point, of course, that's going to slow down. And what's been really interesting is that the DLC, Design Lights Consortium, did a study a few years ago and came up with this delightful graph here that's suggesting that LED product, as we go ahead and move forward, we can expect to harvest more, certainly, energy savings with respect to technology of LED product, but we're also going to start to see more and more requisite use of network lighting controls, right? We'll talk about that a little bit, and we see some of that stuff in the code cycles that we're coming through with. So lighting controls are really going to be up next. So take that for what it's worth. Duane, back to you.
So these are the 4 basic principles that guided our work developing the Seattle Code amendments this year. And today we're going to be looking at lighting and electrical, which together form a pretty critical chunk of all this. Now, the reason I'm starting in with this slide from the HVAC session here is to note that most electric resistance heating is going away, which would include VAV reheat systems. So that will reduce total electrical load in many buildings, while the new restrictions on fossil fuel heating will increase electrical load in others. A couple things to notice in the list of exceptions: you can still use electric resistance heat up until June 1st of this year. That was the last sort of compromise at council. And in apartments, you can use up to 750 watts per room, or 1,000 watts in a corner room. Meaning that if you do a good envelope, you would not need to do heat pumps in an apartment. And beyond that, looking into my crystal ball, I can just see that your future includes a lot of heat pumps. Very similar news for the water heating in hotels and apartments, except that heat pump water heating kicks in on New Year's Day instead of June 1st. So, and we gave everybody that extra year because heat pump water heating is pretty new technology for a lot of engineers, a lot of builders, and just needed to give everybody time to get up to speed on that. Note with that City Council also just announced that they will be considering a proposal to extend this heat pump water heating rule to cover all commercial buildings, except for those with very small loads. So look to see that debate come up in the next few weeks, but they didn't want to hold up the main code development anymore that it's already been held up. So getting back to lighting, our main topic of the day, the controls section is set up with two basic paths. You either do LLLC throughout or follow all the detailed rules for controls. And if you're wondering just what LLLC stands for, just hold on for a few more slides. Note that even if you take this second path, you still have to do the LLLC for OpenOffice. There's a lot packed into this slide, but it seemed useful to let you see it all in one place instead of on a bunch of different slides. If you're taking that second path, you got to use occupancy sensors for a long list of space types, which really comprises most of our non-residential area. In those spaces where you don't have OC sensors, you need sweep controls, and you've got to have manual controls, either wall switches or remote switching of some kind, just about everywhere. Daylight controls in daylight zones, of course, and light reduction controls, you know, the kind that can switch off half your lighting power or reduce it that far wherever you don't have daylight. So that might have sounded confusing, which it is. So right now, I think Shaun's going to walk us through some control strategies and case studies that might make this a little more real for you.
Sure, thanks, Duane. We're going to actually be talking about lighting controls, LLLC, all these things, sort of bouncing back and forth throughout the next couple of hours. So it's not going to be all kind of, you know, here's everything in one row, but it's worth spending a couple of moments, even though some of this stuff is really not new or new to the code. It's worth giving you a quick overview of some of the key items with respect to lighting controls and codes. So as we all know, these are the typical lighting control strategies that we might employ on a commercial project. In fact, the project that you see here to the right, San Francisco Public Utilities headquarters, every single one of the control strategies that you see listed here is used on this project. It's just a 14-story office building. Every single one is used at some point or another in this one project. And this is pretty common. So, of course, what's highlighted in red are going to be the things that we're really most concerned about with respect to following energy codes here: occupancy, vacancy, sensing, daylight harvesting, time scheduling, and so forth. Now, we're not going to give you an exhaustive look at lighting controls in this webinar. However, if you would like an exhaustive look at lighting controls, go to our Lighting Design Lab page. In fact, you can just follow the short link here, the YouTube link, and that will lead you to my network lighting controls class webinar that will give you a very in-depth look at all of the lighting controls that we might be talking about here, right? Duane, can we go to the next slide? But just to give you a quick reminder, right? Here is an example, right? This would be a typical tech office building neighborhood, right? That you might find from almost any of the typical software companies that, you know, we've got a few of those around here. So we've got an open plan office with a window wall. We've got a private office. We've got a smaller team room, and then we've got a medium-sized conference room here. So some of the things to think about from a code standpoint is, let's start off with daylight, right? We've got a window wall there. So we bring in daylight into the space. We're going to have to control the lights next to the window. Well, here in Seattle, and in fact in Washington, any place that the IECC, International Energy Conservation Code, holds sway, we're going to need to actually have two daylight zones here, right? We're going to have a primary daylight zone and a secondary daylight zone. The easiest way to think about this is, what's the window height of the, what's the head height of the window, right? In this case, you don't see it here, but the head height is 9 feet. The room is 18 feet deep. So we have two daylight zones here. First row of fixtures closest to the window is primary daylight zone. Fixtures farther from the wall, secondary daylight zone. So you, at the very least, have to have those controlled separately based on daylight controls, right? You're also going to need to have manual control in there at the very least. Preferably, you might have manual dimming. You're also going to need to have or want to have occupancy sensing or vacancy sensing, right? If you have occupancy sensing, remember, you can only bring that lighting up to 50% light output with the occupancy sensor, right? Otherwise, vacancy sensor, you press the button, lights go on. We have a private office. We want to have occupancy vacancy sensing in there. We have a team room. We're probably going to want to have scene control, but we certainly want to have occupancy vacancy sensing in there. Same in the conference room. Now, throughout all of this, bearing in mind, we're still talking about LED light fixtures. What's the best thing about LED light fixtures? They're all dimmable. Assume that all of this stuff is dimmable, right? Okay, can we go to the next slide? And give you a quick look at what that would really look like in 3 dimensions. And then go to the next slide, please. And this would look somewhat like what we were just talking about, right? So you see that we might have a couple of vacancy sensors in there. We might have a photocell. We might have wall stations that have a variety of different configurations. Now we'll talk a little bit later about the LLLC approach. This is the typical traditional network lighting control approach where we would have sensors that are talking to fixtures individually or groups of fixtures. We'll talk a little bit later about LLLC, which is essentially packaging everything up into one neat little package. Next one, please.
And Shaun, by vacancy sensor, you're meaning that you have to actively turn it on when you come into a space. It doesn't just automatically come up. Is that right?
Outstanding question. So yes, for most manufacturers, the difference between an occupancy or a vacancy sensor is one of either programming or dip switch setting. So basically the idea is with an occupancy sensor, you walk into the space, lights come on. You leave the space, eventually lights go off. With a vacancy sensor, you walk into the space, nothing happens. You have to push one of these buttons, then the lights will go on. Once you leave, they'll automatically go off, right?
And I like that because if you're just dropping a folder off on your boss's desk, you don't need the lights to be on for 20 minutes.
Yep. And just one quick, I'm not going to explain this matrix to you here, other than to say, we'll talk about this a little bit more as well, whoever is designing the lighting control system, we need to have information on how you are intending it to work. This is a matrix that shows a sequence of operations, how everything is supposed to work in that last example. You can do this as a narrative as well. There are lots of different ways to do it. If you go to the class that I had suggested, there are a variety of different examples shown, right? So, and then Duane, back to you.
So there's a whole category of specialty lighting that they've lumped together under additional lighting controls that just needs to have separate switching. So display lighting, accent lighting, display cases, task lighting, fixtures for sale, plant growth, food warming. These just need to have separate switching from the general lighting. Now, in hotel rooms, lights and switch receptacles turn off 20 minutes after everyone leaves, or you use one of those key card controls. In Seattle, we've specifically indicated that includes lighting that's integral with the furniture, since that's the way that hotel rooms are designed these days. Dwelling units, otherwise known as apartments, you just make 90% of the lights LED, which you were going to do anyway. Now, that last one is one that causes a lot of confusion. What the building code calls the exit access is everything between the spot where you're standing or where you're sitting at your desk and the stairwell door or the door to the outside. That whole pathway needs to be lit in an emergency. And the old school way to deal with this was just to leave about one light out of every 6 or so lit 24/7 forever. They have to replace those twice as often. But now code says no, those emergency lights have to turn off when the other general lighting turns off too, and only come on if there's an alarm or a power loss. Shaun.
And that's a great thing, actually. This is a photograph from a trip that I took some years ago to Spokane Public Library. What we see here is a beautifully daylighted rotunda area, and in this case, this was linear fluorescent. Most of the fluorescent lighting's off, right? Except for a 24-hour egress, emergency exit, however you want to phrase it, lighting circuit that could literally never, ever turn off. Looks lovely, doesn't it? So the reality is now it's relatively easy to go ahead and make sure that if you are using your architectural lighting equipment for emergency or egress or exit or however you want to characterize it. There are a lot of different ways that you can do that. Now, normally on a large project that might have a generator feeding emergency circuits, or you might have a larger inverter or battery system that is also feeding emergency circuits. Or you might have a battery backup where you have, if it's true emergency, you might have, say a Bodine battery pack per light fixture that you want to have come on in an emergency condition, right? So you lose normal power, and then you wind up having the battery kick in order to maintain that light. Now, there's also, when we're talking about either LLLC or NLC, network lighting control systems, we have these UL924 devices. A 924 device essentially is a shunt relay. It can either be part of the lighting control system itself, if it is UL listed that way, or it might be a third-party system that is taking both normal power and emergency power. When it senses the loss of normal power in one of several different ways, it will immediately drive the load to full, and it will stay there for a certain period of time, even after the resumption potentially of normal power, so that we make sure that we ride through the emergency event. Duane, can we go to the next slide? This is actually an example of one of these systems. So we have a concept board here where we have a corridor. You'll see that the two light fixtures there represent a normal and a emergency portion of a corridor. I've just turned them both on. Now I've just turned them both off. You can see that they are both functioning exactly as one would expect, right? I can even turn them on and go ahead and dim them up and down so that they completely work in conjunction the way that you would normally expect. But because we have the 924 device on the top that has its emergency feed, as soon as I lose the normal feed, you'll notice that the emergency lights on the top immediately go to full output. Once normal feed in this particular system is restored, you wind up going back to the level that you had before, and you regain the ability to dim up and down. So this is one relatively easy way to go ahead and make sure that we have the ability to control the emergency or egress lights from this kind of system.
And if you're ever wondering what's that soft glow coming from the high rises downtown, can we get this to stop?
Yeah, you just have to hit pause there. There you go.
There we go. That I think that most of the buildings downtown still have all their emergency lighting on forever. Exterior lighting controls. I just love these parking lot pictures. There's 80,000 watts burning there and not a human in sight. So the rules are pretty basic, really, and that's that everything turns off when the sun comes up. Facade lighting and landscape lighting, those two categories, shut off completely between midnight and 6. And with everything else for exterior lighting, which should include this parking lot, you've got to dim the lights either between midnight and 6, or if you're a tavern, maybe from an hour after closing to an hour before opening, with aux sensors that dim the lights after 15 minutes, or with that time clock function. And if you're going to dim them 30%, hey, why not 50? I might say about aux sensors in parking lots, they don't work that well if they're way high off the ground, or if the weather is bad. So make sure you have an expert on board when you're picking those kind of sensors. Shaun.
Yeah, and there are a couple of things, sort of considerations with respect to some of that, and this kind of also circles back to what we're kind of talking about with respect to controls. Remember, parking lot lighting, pedestrian lighting, streetscape facade lighting, all of this is also LED based now, and in almost all cases, it's going to be inherently dimmable one way or another, either with a 0 to 10 signal or similar. So we don't have to necessarily always pick one light level or another, this can be useful with respect to dimming for changing light levels during time, making use of adaptive compensation. So as the nighttime goes on, we can ramp the light level down as our eyes need less light. It also means that we can do things like task tune our parking lots, right? If we're looking for 3, 4, 5 foot candles in a parking lot and we're getting 6, 7, 8 foot candles, we can go ahead and task tune that down, which gives us some remarkable savings right there, right? Scheduling, astronomic time clocks. So Duane has mentioned occupancy sensing. Occupancy sensing, yes, it does require some effort, some thought. A lot of the manufacturers are starting to really get on board with exterior occupancy sensors, useful for not just parking lots, but also pedestrian lighting, right? So if you've got, say, a campus, dim your pedestrian lights down to 20% light output unless there's somebody there, and then bounce it up to full output when somebody is there. Another thing to think about, and it's funny because this isn't on anyone's radar yet, or not a lot of radars yet, but tunable light is coming even for exterior lighting. There's some specific discussions about it in a variety of places going on. So look for those things to be coming up in the future.
And I might add that campus security people and hospital security people really like parking lot lights that dim down considerably at night. And the reason is that they can be a quarter mile away and see lights starting to come up over someplace and go and check out who's over there because they weren't expecting anybody to be moving around. So it's a little counterintuitive that lowering lights increases security, but it sure works.
Duane, this is going to be, I'm going to ask if we can pause here because we have a couple of questions that would be potentially useful to answer. One of them, what lighting control exemptions are there for security or 24/7 operating facilities?
Well, basically that's a get out of jail free card. So obviously if a light is intended to stay on forever, like for instance, the light that's at the ATM, is not supposed to go off, at least not supposed to go off during the night. That works, but we're never going to compromise people's personal security and safety with this, and so you won't get a lot of flack unless the argument is stretching things a little too far as for what is needed to be security. Did I answer the question, Shaun, or is that?
Well, you actually brought up something else, which is a really good sort of discussion point, which is to say that, and correct me if I'm wrong, Duane, but my working with code officials through the years on projects has always been one of collegiality, right? So it's a question of if I'm trying to do something that needs some discussion, as long as the discussion is reasonable, right? Whatever it is that I'm trying to do, it's worthwhile to engage your local code official to discuss it. So, for example, in this case, it's an exemption for a 24/7 operating facility or something that has a very specific security exemption. Talk with people, right? Have that discussion. Does that seem fair?
And yeah, if you work for the building department for very long, you start to get kind of cynical because there's a parade of people coming in trying to get away with something. But if somebody comes in and has a situation where you can agree it's extremely difficult, and they're coming in with a suggestion that instead of doing it by the book this way, they have this other procedure they want to follow that would keep things safe and save energy, we'd love to talk with you.
Okay, sounds good.
Did you have any more there?
So Perry has one similar, 12 to 6 a.m. exterior lights. Are there exceptions for industrial exterior areas that have graveyard shifts with areas part of the work activity area? So I suspect that that's really basically the same answer for that, which is it's a 24/7 operating facility. So if there is an actual need there, for example, if the Port of Seattle is working 24/7, the high mast lights aren't going to be expected to go out from 12 a.m. to 6 a.m. So I think in a lot of ways, I guess I would say that this may be a very overused phrase, but common sense goes a long way to interpreting some of these things. Right?
Yep.
Okay. Why don't we jump on from there?
Okay, so going from outdoors back to indoors. So Washington State took on the new lighting table values from ASHRAE 90.1, which averages, area weighted a reduction of about 11% of lighting power from the previous Washington State version. A bonus prize in this is that there are 20 mostly smaller space types, like nurse stations, for instance, that actually ended up getting a bigger allowance. When they did this analysis, they recognized that with small spaces, you can't get that kind of efficient layout that you can get with larger ones. Now, Seattle reduces those by 10% across the board, except for a couple of categories: healthcare, correctional, and facilities for vision impaired people. This 10% is not just arbitrary. Like we saw back on that first slide when we were talking about progress in lighting efficacy, LED lighting is getting about 5% better each year. And the data from the ASHRAE study was taken in 2018. Buildings applying for permits under this new code will get their lighting installed in anywhere from 2022 to 26 timeframe, by which time lighting is 30% more efficient. So the 10% reduction seemed modest, if anything. There's also a bunch of footnotes under that lighting table, and we picked up a number of these from California. The classroom is like, you got that whiteboard there. You've got 4.5 watts a lineal foot, in addition to the general lighting you've got. And there are several spaces that get a bonus for ornamental lighting. Keep in mind that the general lighting allowance for many spaces is down around 0.5 or 0.6 watts now. So a bonus of 0.3 watts a square foot is a lot. That's raising it, by 50%, right? You can get extra for task lighting in labs and offices. And note that in Seattle, we've added an allowance for corridors. And that last one is an example of a lighting designer calling me up to say that the code just made it about impossible to design a hotel corridor that didn't look like a prison corridor. And I didn't really believe her at first, but then I looked up some catalog cuts and did a little amateur lighting design for a hotel corridor, and lo and behold, she was completely right. So this is ideally how code gets written, that we have input from you people who are out in the trenches, and that informs the way things get written. Oh, and germicidal lighting. By the time the new facilities we're designing now get built and occupied a few years from now, we're all going to be slammed by some new crisis that no one's thought of yet. But for now, everybody's frantic to do something, anything, to protect people from COVID. So, hey, germicidal lighting, pop it in your, maybe in your HVAC ventilation outlets, and you might save a life. Shaun.
I will say that those additional allowances are really, really useful. They're a great addition. In particular, it's when you're doing a large project, you can have tradable spaces, and that gives you a lot of flexibility. If you're doing, for example, a lobby and corridor project, you wind up having a somewhat different sort of calculus how you do things. So do consider those allowances and some of the flexibility that they render. I'll give you a few examples here as we jump through. And so Duane had asked me to put together some examples of new projects, and they're not necessarily completely new because everybody's really busy. It may surprise you all to try to compile some things right now from local designers who are digging in the trenches right now. But I have a couple of examples here. Here's a typical open office. This is from a local software company. And one of the interesting things, we completed this in really 2015, but the final, I think, was early 2016. And you'll notice that it's a typical general office space, right? There's daylight there. This is not entirely dissimilar to the tech office example that I gave you earlier with respect to lighting controls, right? But in this particular case, the target light level is 25 foot candles. We actually measured a little bit more than 30 initially, which gave us some room for task tuning. And of course, it had occupancy sensing, daylight harvesting, all that kind of good stuff. But this is from 5 years ago, and our allowed watts per square foot with the new code, 0.55, right? The actual lighting power density there is 0.42. Now, this is simply to show you that it is certainly possible to meet and exceed the energy code as we currently have it. Can we go to the next one?
Yeah. So you beat that current target 5 years ago by 30% with a really nice lighting layout.
Yes. Now the caveat to that is that, again, we're looking at tradable spaces, right? In a big project, there are going to be some areas that are going to be under, some areas that are over, but it is absolutely possible to do it. Here's another example. This is a classroom. Now this is actually North Seattle Community College Allied Health Building, and I'm cheating here a little bit because what you see in the photograph is in fact the space that you see in the drawing there. What I'm cheating about is that this project was done more than 10 years ago. This is fluorescent, however. So what I was interested in was, well, if I had this exact space and I wanted to do the exact same lighting, and I did it with LED using the exact same approach, the exact same types of fixtures, what would that come up with, right? We have the same occupancy sensing, scene control, daylight harvesting, all those things. So my allowance for a classroom is 0.64 watts per square foot, right? Plus the 4.5 watts per linear foot for the whiteboard. So my overall allowance, looking at both of those things, is 953 watts. So if I look at my general area lighting, well, that became 720 watts with LED, 120 watts of perimeter lighting, that's at the window wall there. Whiteboard is 90, my proposed is 930 watts. So again, this is just a quick example of how you can meet that. But now what's interesting about this? Well, this is a classroom. Duane, can we go to the next slide? But this is actually a lab classroom. So if I was submitting this as under the energy code, I'd actually submit it as a laboratory classroom because that's what it is. So my allowance there would actually be 1 watt per square foot, right? So I would actually have an allowance of 1,428 watts where I am proposing 930 watts. So this hopefully will give you some kind of example of how some of these things can be accomplished. Can you go to the next one? And this is a corridor example, right? This is just to give you this is a fairly atypical corridor, I'm going to tell you. This is from Tommy Bahama's headquarters, done a couple of years ago. And this is what would make use of the 0.25 watts per square foot for display and decorative, right? Because a lot of the lighting in this particular corridor is, in fact, display, looking at photographs or imagery, and decorative, looking at those pendants there. So my total allowance is 1,035 watts. My installed light fixtures are 820 watts there. And of course, the big note here is that this is reviewing a sample segment of this corridor. The corridor is much larger. There's several of them on the project, but they're really quite similar, right? That idea is that it's not terribly difficult necessarily to meet this particular energy code when we have the allowance that is moving forward. Now, if we go to a more prosaic kind of example of a corridor, this is actually a study that was done. This was a Delta snapshot that the LRC, Lighting Research Center, put together last fall at some point, as I recall. And what they did was looked at some multifamily housing in upstate New York, and they looked at replacing lighting fixtures, fluorescent lighting fixtures, with LED lighting fixtures that had LLLC, essentially luminaire level lighting control, had the dimming, had the occupancy sensors on board. What they did was a one-for-one replacement. They went ahead and, of course, you can see they rotated the light fixtures so that they aligned with the corridor rather than being transverse. One interesting thing, they went ahead and they increased the light level from 100 lux 10-foot candles to 300 lux. It's not necessarily something that you would have to do, but it is an interesting thing from a lighting power density standpoint, because they're at 0.38 watts per square foot, which is actually even increasing up to 30 foot candles, which is higher than the recommended light level per the IES. They're at 0.38 watts per square foot, where our new code is 0.37 watts per square foot with no additional allowances, right? So by going ahead and doing this, they dropped to 20% light output when no occupancy is detected. And they didn't have to do any rewiring or anything to get that kind of controls bonus. You can go ahead and get this Delta study from the link here. Just Google Delta multifamily to LRC if you can't grab the link. Can you go to the next one? This is kind of the result that they had. 78% of the occupants that were in the facilities approved of the dimming down to 20% light output when nobody was there. And I can tell you, getting 78% of anybody to approve of a lighting control scheme is fairly significant, right? A couple of the really key learning things was, we always talk about timeouts for occupancy sensors. Is it 30 minutes? Is it 15 minutes? Is it 5 minutes? Personally, I like 5 minutes. I like short timeouts, and that's frankly because the reason that we used to use 30 minutes had everything to do with the lifespan of fluorescent lamps, which we don't have to worry about anymore. So if you're going to use 5 minutes, you're going to use 15 minutes, whatever that happens to be. They didn't mind the dimming to 20% when nobody was there. So you walk out of your apartment, you're not in darkness, you're at 20% light output. As soon as the sensor sees you, it bounces up to full brightness. Using the sensors more than doubled the energy savings. So they had a 33% energy savings just right out of the box by replacing the light fixtures. Now, remember, they could have had a much higher energy savings there if they had gone to a lower light level rather than tripling the light level, right? Adding in the controls, they see a 73% savings. And you'll see here, even at a 15-minute delay, the lights were in the low output 70% of the time. And the key thing here is using the LLC wireless controls, there was no additional wiring or complexity. One-for-one replacement, real simple. So, and one more thing, Duane mentions germicidal lighting. Sorry, yeah, there we go. We've known since the 19th century, at least, that ultraviolet radiation is useful for disinfection. There's nothing new here. In fact, you can get, in fact, I have some fluorescent lamps. They're essentially fluorescent. Take away the phosphor, they're no longer fluorescent. We call them low pressure mercury tubes. So the mercury arc tube emits a radiation in the 254 nanometer region. It emits some others as well. But we tend to use either low pressure mercury tubes or excimer and several other different technologies to do things like disinfect water. We've long used these kinds of tubes to disinfect upper air spaces within things like tuberculosis clinics. So there's nothing new here, and lighting them on surfaces. I will say that there it's a bit of a misnomer to call it ultraviolet light, because it's by definition not light because you're not seeing it, right? But it is electromagnetic emission. So if you go to IES, again, Google IES GUV, and you'll get there if you can't grab these links. Although I'll try to post the links in the chat at the end if I can. Go to these things, and they'll have really good information about germicidal UV, the benefits, the drawbacks, and some of the cautions that you want to pay attention to.
And Shaun, is it clear that this is effective with COVID? Is that known?
It's basically known. I don't know that anyone's done a true COVID test, but there is test data, I believe, from the earlier SARS version, right? So, and I'm sure that the testing is sort of ongoing. But there are several different issues with respect to this. One is dose, right? How long are you dosing for? One is intensity. One is shadowing. You know, you can't, for example, just go ahead and put one of these systems in a room and expect the whole room's going to become sterilized, because it's only where the ultraviolet light is hitting, right? So I'm gonna stop it there. IES is your best option for that.
All right. So our favorite indoor gardening crop here, micromoles per joule. That measures the light that plants use for photosynthesis, which is a way bigger band of the spectrum, like you can see there, than what us humans use for vision. So 1.9 micromoles allows both LED and double-ended HID fixtures. LEDs are now available with values over 3, and like I think I even heard 3.7. But not all the growers are convinced that LED will create that special sauce they need for their mystic purple tricycle blend or whatever it is that they're selling. So I'm still expecting that over by next code cycle, probably people will have settled into believing in LEDs or some variant on them. It used to be, recently I was still doing this. I'd use photographs that I got from county law enforcement, but now it's all legal. So our favorite new acronym we've mentioned several times already.
Can we do a quick time there?
Yep.
For a few questions. Also, it'll be interesting if indoor ag becomes the driver for LED improvements. That'll be kind of funny. There are a few questions here. Apologies, I'm not going to get to all of them, but let me ask a couple of them that are fairly germane. We'll try to circle back for those of you whose questions may be we addressed towards the end. If the Seattle Energy Code is 10% below Washington Energy Code, and 2018 Washington Energy Code is 11% below 2015 Washington Energy Code, then 2018 Seattle Energy Code is 21% lower than 2015 Energy Code.
Wrong. Seattle, actually, our current old code is also 10% below the state level across the board. So really both the state and Seattle are reducing by 11% for most spaces and increasing somewhat for smaller spaces.
Okay. A lot of what we're talking about costs more money up front on projects. Does the LDL have studies or tools to help show owners, developers financial payback for using the advanced controls or better LED packages? Obviously, first cost is a huge driver for buildings, but if we can show 3, 5, or 10-year payback for technologies, that would be helpful. We don't necessarily have specific tools from a financial standpoint. And in fact, I will tell you that a lot of, particularly with respect to controls, The biggest benefits, frankly, are going to be the non-energy benefits, higher productivity, happier workers, better flexibility in your spaces. Those are really going to be the drivers. And frankly, light and health is going to be another one of those. We're not really talking much about light and health in this particular topic, but it's becoming clearer and clearer that light has a very specific effect on your endocrine system, and that's going to be a big driver in the coming years. And there are 5 or 6 key variables with respect to that, and almost all of them are directly controllable by lighting controls. So Paul, if you want to see more of that, go ahead and look in the Lighting Design Lab recorded classes, and you can look at both the light and health class that I delivered, as well as the lighting controls, network lighting controls. Those will both help you there. Acronyms, LPD. Thank you, Perry. So for those who are not sort of familiar necessarily, as we're tossing around some acronyms, or I am anyway, LPD stands for lighting power density. LPA stands for lighting power allowance. Thank you, Perry. Let's see. Okay, a couple more of these questions are really a little bit more in depth. So I'm going to say that we will try to circle back for some of those, and for the moment, let's go ahead and continue on in the interest of pushing through.
Yeah, and I should say about cost, one of the big, I think the big driver of the overall conversion to LED wasn't energy savings, it was labor savings, because they last so much longer. Maybe a lot of you remember from the fluorescent days that there would be some guy with a cart that would be coming around. He had a little step ladder, and he was changing out lamps, changing out ballasts. In a big building, that might be a permanent employee that just ran through the building forever, and that person doesn't need to be doing that job anymore. Another thing about cost is that things that cost more because they're kind of a high-end special order thing, once they become code mandatory, it's business as usual, and that's the only thing that the suppliers stock, those incremental higher costs come down a lot, because the miracle of capitalism kicks in and people start competing on cost there. So our new favorite acronym, LLLC, it's luminaire level lighting control, and that's to differentiate it from room level lighting control. I guess that would be RLLC. So in this case, each fixture or small group of fixtures is fitted with its own occupancy sensor and daylight sensor. They each have a wireless controller on board. So this year we've made LLLCs mandatory for large open office spaces. And the great savings about this is that when your work group all goes into a conference room, you all remember conference rooms? It was back in history somewhere. If for a 2-hour meeting, or when everybody goes out for a retirement lunch or whatever, the lights in your area will dim down until people start coming back, and then they bounce right back up to full power. And it turns out that most office workers are away from their desks more often than they're sitting at their desks. So this can save a huge amount of electricity. I've seen 40% bandied around, as well as taking stress off the air conditioning in summer. Now, one of my lighting designer friends complained that the really architecturally cool, stylish fixtures aren't available in LLC at this time. So we made this alternate path available that lets you use a network lighting control system instead. These are pretty fancy, but we've seen them used in a lot of high-end office projects thus far. Shaun.
Okay, we promised you that we would talk a little bit more about LLLC. Just rolls right off the tongue, doesn't it? LLLC. For those of you who have been in the industry for a time, you may also recognize these as something we used to call them vertically integrated lighting systems. As with most things about lighting controls, they're not particularly new. What is new is that they actually really work well now, and that they can integrate into a larger network lighting control system, which is huge. So what are we talking about when we're talking about luminaire level lighting controls? Essentially, we have a light fixture that is its own unique control zone. Every light fixture is its own unique element. Within that unique element, we wrap dimming, we wrap logic, we wrap usually some level of communications, and that's frequently wireless. And then we also have sensing technology. So most of the time that means occupancy sensing, vacancy sensing, and daylight sensing. Sometimes that means other things. Some systems will allow you to do things like CO2 monitors or temperature monitors, a variety of different things. But the idea is that everything gets wrapped together right out of the factory. So instead of having to pair devices, instead of having to run additional wires, you basically throw your light fixtures up into the ceiling, have 3 connections, a hot, a neutral, and a ground, and you're done. Then everything else becomes programming. Duane, can we go to the next one?
Yeah, and Shaun, that feeds into that question about cost as well, because the fixture is going to cost more, but not, wiring.
I'll get there. So there are a lot of considerations that go into this notion of luminaire level lighting controls, and there are a lot of resources out there that are available for you. Here actually is the front page of a tag sheet that has been put together by City Light, NIA, and some others to really give you some ideas. Those things are available if you go to lightingdesignlab.com/resources. You'll see all kinds of different information that's available for both network lighting controls and luminaire level lighting controls. It's important to understand that in most cases, luminaire level lighting controls are a subset of network lighting controls. The idea is that they're meant to work together. As Duane has mentioned, not every light fixture is going to be available as a LLLC fixture. So it's going to be important for a project to have a unified lighting control system so that the LLLC fixtures can communicate with the broader context of your downlights, your accent lights, your whatever they happen to be, so that the end user really only has to operate one control system. This is why these are so much better than the older vertically integrated luminaire systems. So a couple of things about them. They simplify zoning and documentation, right? Why? Because they're all their individual zones, so you don't have to think about that beforehand. They simplify code compliance documentation. Why? Because they automatically comply, right? You check a box in most jurisdictions. They maximize flexibility. They do provide some plug and play functionality. So if you have a project and you're a lighting controls whiz, that's fantastic. If you have a project and you're not a lighting controls whiz, most of them come from the factory with a certain level of programming already inherent in them, so they'll get you to 80% of the savings that you need right out of the box, even if nobody touches them again. We're not advocating that, but if that's the case, there is some helpful there. Now, like I said, they simplify installation, particularly in retrofit projects, but they do add some capital cost, as Duane has mentioned. Typically, they're $30 to $75 extra per luminaire, depending on the fixture, depending on the system, depending on the complexity. Now, interestingly enough, if you're doing a retrofit project in particular, that capital cost might be offset by utility incentives. Most of the utilities in the Pacific Northwest, Seattle City Light, for example, is offering $50 kicker per LLLC fixture that gets installed in the system. So that more or less entirely offsets the control cost, right? But the big thing here is the simplicity, right? It saves design time, it saves installation time, a lot of good opportunities there. Can we go to the next one? Let me give you just a quick example. So I showed you the TechX office earlier, right? Where we showed you that we had a daylight control zone, primary and secondary, and then we had a variety of other places. So from a design standpoint, I would have to decide exactly how I wanted to configure these rooms beforehand so that we would be able to go ahead and have the wiring done correctly between the individual light fixtures. Well, what happens if I want to have more flexibility, or I want to have the ability to change over time, right? Maybe I want to throw in a demountable partition somewhere and turn this open office into several private offices. Well, if I'm doing that with a network lighting control system, I'm likely going to have to do some rewiring. If I'm doing this with the LLC approach, I have some programming to do because each one of the light fixtures are individually addressable, and they all have their own sensors, right? So it really, in a lot of ways, simplifies the upfront stuff. Can we go to the next one? Now, some of you may, I hope most of you, in fact, will know Lighting Design Lab alum extraordinaire Michael Lane. Michael is in charge of lighting over at our sister utility, Puget Sound Energy, right? Another utility in the area. They did an LLC pilot, and this goes back to 2015. So again, this is going back a couple of years. They retrofitted 11,000 square feet of their offices from 67 T8 2x4 parabolics to 100 2x2 smart troffers, right? More light fixtures, but better lighting distribution, better lighting, and they're smart. So their connected load comes in at 0.56 watts per square foot. This was 6 years ago. What is our current open office lighting allowance now, Mr. Duane?
I forget.
0.55. So 6 years ago, it was 0.01 higher, right? Now the fixtures are equipped with occupancy, vacancy, daylight harvesting, task tuning. All these things are all together, wireless control. The key thing here is that the staff loves it. Much better lighting, happier people there. But oh, by the way, they had 35% energy savings from the light fixtures, right? But when you add the light fixtures and the controls together, it's a 72% energy savings. Now, there are going to be people that say this is an outlier. I'm going to show you a couple of other examples as we move forward with some of these things, but it's not. The savings are there.
With that example, how far down did they dim when people were away from their desks? Do you know?
20% is my understanding during daytime hours.
Okay.
And that's normally my preference, is during daytime hours, dim down to 20, after hours, dim down to 0. That seems to make people happiest, right? NEA, Northwest Energy Efficiency Alliance, commissioned a study that finished up in September. And they did a test bed with a 1,000 square foot office down at the University of Oregon. And you can go ahead and download the study. It's available here. Their key findings were that doing a one-for-one replacement with LLC versus doing a complete redesign with a typical network lighting control system actually maximized the energy savings. So the replacement gave us somewhere between 50 and 74% savings, depending on the configuration. Redesign was 59% energy savings. But the replacement, the one-for-one replacement, was a third to a half the cost. So you're getting more bang for your buck with less money there. And you can look at the details at the NEA site. Next one. And final one, as I'd mentioned, there's lots and lots of resources available. We have an entire series on network and LLC lighting controls available at the Lighting Design Lab. And also, again, the classes that are recorded from our network lighting control series. So all this stuff is available to you, again, thanks largely to City Light, so, and NEA as well. So, Duane, I think back to you.
Okay, here's one little non-lighting requirement you should know about if you do multifamily. Any gas appliance in an apartment has to have a suitably sized and circuited outlet right next to it so that conversion to a future induction stove would literally be plug and play. Controlled receptacles, half your outlets have to be controlled receptacles in this list of spaces. So you plug your monitors and desk lamp and music system into the controlled outlet so they turn off automatically when you're not around. But your classroom aquarium, your office server, they'd stay plugged into the non-controlled outlets. Wouldn't lose power ever. You can see in the diagram that once we shrink the energy use of all those regulated loads that show in blue and tan, the plug loads in red start to be a very big percentage of the total. So a strategy to reduce the plug load energy is critical to reach these carbon goals. Feedback I've had is that split receptacles work best so that everybody knows that the top outlet turns off on weekends, but you can also have pairs of controlled and uncontrolled outlets within 12 inches of each other. And finally, a lot of us are getting these ergonomic adjustable height desks now that have their own outlets built in, and these are typically just plugged into the non-controlled power. But that's a problem I guess we'll have to resolve in a different code cycle. So, Shaun, vampires.
Well, and I just wanted to toss in there that it's an interesting thing because there are an awful lot of vampire loads out there that this is meant to address, right? That whether we think about it or not, task lights get left on overnight. The platen on printers or large-scale OSE plotters, for example, wind up staying heated overnight so that they can print things very quickly. Microwaves, oddly enough, become a big thing. So there are a number of different vampire loads out there that we really want to pay attention to. But we always get but I plugged my CPU in one time and I lost some stuff. Great. You know what? Plug everything but your CPU into that controlled outlet. Put the CPU itself in the non-controlled outlet, call it good, everybody will be happy. One thing that is really interesting though is if you're doing a project, try doing an inventory of what those plug loads will be sometime. So I used to run Luma for PAE engineers here in Seattle. Our office was up in the Bullitt Center. When we were doing the Bullitt Center, we actually did a fairly involved inventory of all of the plug loads that we were going to be using for everything from our task lights to our microwaves to our kegerator, everything. We wanted to have a good sense of what those things were and how we could minimize those loads. Hit the next one, please, Duane. And this just to give you a quick little sense. This is from sort of early on in that process. You know, we're looking at a typical building at that time. We were looking at 20% energy use for plug loads for that kind of office building, right? We in the Bullitt Center managed to drop that down to 11%, which seems huge and all, but it's still 11%, right? I mean, there's a lot of power that you're still using, even in a building like the Bullitt Center. So do pay attention to this stuff. And as Duane, as we'd alluded to earlier, sometimes we hear people trying to circumvent different parts of the energy code. This is a really easy one. You can use this, particularly with network lighting controls, either with 20 amp relays connected to the lighting control system, or at least 3 different manufacturers now have smart receptacles. I use one in my wood shop. So they're really quite robust, and they allow you to have that level of control really simply, particularly for retrofit applications as well. Okay, back to you, Duane.
Okay, so C406 is our place in the code where we require every project to pick a couple of above code options from a list of a dozen options. And at the top, I've highlighted 4 of them that pertain to today's session. We've got 2 levels of lighting efficacy. Is that efficiency or efficacy? Some lighting controls and renewables. So for instance, if you choose the 10% lighting power reduction for an E occupancy, that'd be a school, you get 2 credits. And in Seattle, you need 8 credits total for your building. Elsewhere in the state, you need 6. Shaun, can you really exceed code requirements on this?
Yes, although I'm going to also kind of come back to, I'm going to look at several specific areas, several specific typologies here, and remind everybody that there's a lot of trading back and forth between spaces and tradable spaces, but it's absolutely possible to meet these code requirements. So I'll give you a couple of examples. Some of the things that we've already seen. The software company that we saw earlier, the open office exceeded code by 24%, current code as of yesterday. Tommy Bahama corridor exceeded it by 21% with that decorative and display allowance. The lab classroom example that I showed you exceeded it by 35%. Now it's important to understand not all projects will be able to meet these things. And not all clients, for designers out there, not all clients are going to kind of be forward thinking like some of these folks who are embracing these things. But it is possible and we can push forward with it. Let me give you a couple of examples. Miller Hull is a fantastic architecture firm in town here. In 2017, I redesigned the lighting for their space. They're in the Polson building downtown, Pioneer Square. They have an entire floor plate in that building, 14,000 square feet. They used to look out onto what used to be the viaduct, and now they have a somewhat less encumbered view. Can we go to the next slide? Next slide, Duane. Duane, are you frozen?
Do you have the next slide?
Not yet. I'm still looking at 46. We went one too far. Go back one. There we go. Perfect. So again, this was 2017. Miller Hull Studios. Their existing lighting in that space had been done in the 90s with a predominantly indirect fluorescent system. It was actually pretty good for the time, but it was 1.14 or something like that watts per square foot. We replaced the lighting, we added lighting controls, it used to be that they would have one control zone. You walked in, you had one person working on a Sunday, all the lights in the entire floor plate were on. Now we have it zoned much more finely so that they can have significant energy savings from lighting controls as well. At the end of the day, we've improved the lighting radically. We've added the lighting controls. They have much happier staff, and we're actually down to 0.3 watts per square foot on the entire floor plate. So the allowance for an office building is, I think it's 0.58 watts per square foot, right, per office building as an aggregate. So we're 60% better than the code here. Now again, this may be something of an outlier. We've got great daylight. We've also got a client that is very, very heavily engaged in sustainability. If we add in the lighting controls, we're actually probably down to an effective lighting power density of about 0.15 watts annualized, something in that range. Could go to the next one. So I wanted to give you just a quick look at this. Obviously, is a calculation run and an estimate, but I showed you earlier the North Seattle Community College tech office building, and that had some sense to it. But here is a potentially more typical kind of look at a classroom, right? So this is a 30 by 30 classroom. We can mix and match the dimensions however we would like to. But in this particular case, it's 8 foot tall. It's got a window wall, a south-facing window wall in this particular case. We've got some general area lighting, recessed or semi-recessed 2x2s, and then we've got lighting at the front at the whiteboard there, making use of the 4.5 watts per linear foot allowance. So if we are going ahead and meeting our target light level of course is 30 foot candles. Our estimated light level here is 36 foot candles. The total allowance is 684 watts. The proposed is 414 watts. So in this particular case, it's exceeding the code by 40%. Now, I would say that if I was designing this, I'd probably give myself a little bit of latitude and maybe only try to beat the code by 20%, as Duane is suggesting. But it is possible to do. Can we go to the next one? Same classroom, but in this particular case, it's indirect direct lighting because we've bumped our ceiling up to 10 feet, right? So we've got that height to provide us what is, frankly, from my perspective, better lighting. If we can get that higher ceiling, we get better daylight within the space. And then we also get the ability to have indirect direct lighting, which is personal preference. Similarly, right, the allowance remains 684 watts, our proposed is a little bit higher because we're doing indirect direct lighting, but we're only exceeding the code by 35%. Shocking, but essentially the same kind of light level. Now, I'll give you a real quick case study. Some of you have seen this before. This is my office is in the Bullitt Center. TI renovation completed in 2017, 6,100 square feet. And the tenant was a consulting engineering firm, right? So if we jump to the next one. So, we put this relatively high performance lighting design together. 2017, our power density was 0.55 watts per square foot. That's actually a little bit artificially high, in fact, because I intentionally overlighted the open areas there with the linear LED with the idea that I wanted to intentionally task tune down by about 30%. So that I could go ahead and increase the lifespan of the LED lighting system that we had in there. Right now, today, the LPD proposal is 0.58 watts per square foot. We'd also gone ahead and designed in all of these controls that we would normally expect. Go to the next one. Of course, I made the cardinal error of going on my honeymoon for 3 weeks when the construction was happening. So I wasn't there to say no to a controls value engineering proposal that radically changed the ability of the lighting controls to function. In fact, it was not even possible to fully extinguish the electric lights, which I can tell you for a building where we have essentially a world-class building with people coming in for tours, that's not necessarily the best thing in the world to be happening. So we went ahead and we did a lighting controls retrofit using one of these networked lighting control systems. We went ahead and put in essentially a load controller per light fixture. So while they're not LLC fixtures, because as sort of Duane had alluded to earlier, some fixtures, it's literally not physically possible to attach a sensor to them. These are one of those. But we did have individual light fixture control, so every fixture is individually addressable. And then we added in all of the high-end controls. Duane, in looking at this, Duane had asked me to put together a slide or a series of slides that would show high-end lighting control. This used to be high-end lighting control. 10 years ago, this would have been only possible with the highest end lighting control systems that we had. Today, this is actually the budget system. This particular system is a parts and pieces approach, relatively inexpensive, easy to put on everybody's projects, and incredibly flexible. And you're seeing one manufacturer's version of this. When I teach my network lighting control classes, I use 8 different manufacturers here. They are all fantastic. So there are lots of manufacturers that can do this. Go to the next one, please. And so the results, the best result was that we could turn the lights off and dim according to where we wanted to. It used to be you couldn't turn the lights off. Next one. And the key result here was that we actually had more than 70% effective reduction in energy use, right? And this was metered. The Bullitt Center is one of the probably most highly studied buildings on the planet. I can tell you that the more than 70% effective reduction is well documented, right? And from a cost standpoint, somebody had mentioned cost. Again, from a performance standpoint, this is 10 years ago would have been considered super high end from the performance capabilities. At that time, we would have been talking about $2 to $3 per square foot at least for lighting controls. This at retail cost, I came up with what the retail cost would be 78 cents per square foot to do all of these things, right? So from a project standpoint, it's significantly lower than 78 cents a square foot. So I hope that gives you some sense of some of the abilities with respect to costs and particularly with retrofit, because this, of course, is a retrofit system. We went ahead and retrofitted it ourselves very quickly, very easily. Great little system. Again, I work with 8 that could do exactly the same thing. Going back to you.
Okay. moving to solar here, you can see the chart that I crossed out on the right. That's the way the state code does the solar option. There's a different target amount for every building type. So it's a breeze for a theater and extremely heavy for a restaurant. And you have to calculate the annual energy production, which means you've got to find somebody who can calculate the shading on your roof, a roof that isn't there yet, and the cloud cover and everything else. So for Seattle, I've just made it as flat 1/4 of a watt per square foot of floor area for 3 credits. And based on stakeholder requests, I've also given you the option to just go for 1 or 2 of those credits if that's all you need. But now I'm going to introduce Reeves Clippard, partner at A&R Solar. Reeves, is R for Reeves?
Yeah, indeed it is.
Okay, well, take it away.
Great, thanks. So just so you all know who I am the R of A&R Solar, Reeves Clippard. I'm CEO and co-founder. We've been around for 14 years, based here in Seattle. We install solar on residential and commercial properties, government, community solar projects like that. Happen all the way across Washington and Oregon as well. We have a satellite office down in Portland. And so we've been doing this for a while. I've actually been in the industry a few years longer than A&R has been around, but let's get to the code. So what you see here is, Duane mentioned there's a couple of different pathways to compliance, right? So the bottom bullet point there is the 25 watts per square foot code that was just mentioned. This is going to lead to about 200 solar panels, depending on code requirements. And so this is a great update to the code. It's a really better designed and more functional solar array, which I'll get to here in a second. And the big point being that this is a better way to recognize the financial benefits of solar. So this is where building owners and operators are going to see the best bang for their buck. So just 3 key things for you to know about what a solar array needs to be functional is you need the panels and a place to mount them out of the sun. And there's some great code guidance on that. You need a way to mount them to the roof. In these 2 pictures, you see what are considered ballasted arrays, where we are just using a ballast block to hold the panels down to the roof. So there are some structural requirements there. And I believe I've got a slide here in a minute that talks a little bit more about that. And then you need a way to interconnect to the electrical system. And so that can be done in a number of ways, whether it's in a sub panel close to the roof or on a penthouse or even down in the main electrical room. And there's some different requirements that happen there. But what I really wanted you to take away from this is what you see again at the bottom would be if you're going for all 3 credits, what an array might look like versus if you're just looking for a single point. It's going to be a much smaller array. In fact, we see some systems that are only 4 panels. Now, why the larger systems are more cost effective is you need to think about the amount of coordination that happens with this new trade, which is a specialty solar contractor. There's going to be engineering, design work, permitting, lifting, hoisting, all of these things that happen no matter what the size of the array is. And the main difference that you see between these 2 pictures from a delivery standpoint is once you've done all of that interconnection, once you've done all the design work, the engineering, the permitting, and gone through all those coordination exercises, is that the labor to add 1 more panel or 10 more panels or 20 more panels is relatively cheap compared to the rest of that infrastructure that goes in. So the larger the array is, the cheaper per unit it gets. So y'all are more used to thinking about watts and watts per square foot. A key metric in solar is cost per watt. So for these smaller arrays, you might be looking at, let's say, an average of $10 per watt installed. Whereas for the larger arrays, you might be $2 or $2.50 per watt, up to $5 a watt, really depending on a number of factors. And solar contractors should be able to give you a lot of guidance there. Let's go to the next slide.
Well, let me just introduce that. For solar readiness, you've got to make 40% of your net roof area into a solar ready zone, which basically just means drawing a couple dotted line rectangles on the roof plan and setting up your main service panel to accommodate future solar. The area inside those dotted rectangles has to be free of clutter and able to handle the extra 4 pounds a square foot. And by the way, to get net roof area, you subtract any skylights, decks, planted areas, so forth. In Seattle, we also subtract the area of rooftop mechanical stuff, and then you take 40% of that net. The whole idea is to make this literally plug and play so that when the cost of solar comes down so far, but maybe Reeves has some other ideas about how to bring down the cost here.
Yeah, and on that, we have seen the cost of solar modules just plummet over the last several years, and it has kept going. But there is a lot of volatility in our market right now. A couple years ago, we had tariffs that were introduced along with washing machines. Solar were some of the first tariffs. Those are stepping down, but we don't really expect solar module prices to come down after that. So we're hitting some floors. Other cost savings coming through standardization, better coordination, things like that. You're going to hear me say coordination a lot because where we see projects are successful is where there is smart coordination with the solar contractor, that it's not an afterthought, versus projects where people say, hey, quick, we have some compliance that we have to do. Just get it up here. So coming to the structural considerations, one of those 3 points. As mentioned, within the code is the 4 pounds per square foot. A lot of systems and even ballasted systems are able to meet that requirement, but a lot of them aren't. And so why is that? The higher the building is, the more wind load, the more forces wind is going to put onto panels, and the more weight that you're going to need. So as we get into higher and higher buildings, you're going to need more ballast, and you might need more attachments. Sometimes attachments are needed for seismic as well. But once you get up to a building height of 60 feet or above, you can expect a lot more attachments, because really ballasted systems going to be more in the, I'll call it like 8 to 12 pounds per square foot at the high end. And so what you can do is you can have what's considered a hybrid system, where you're using as much ballast as the roof loading will allow, but then you're also adding attach points to prevent some of those uplift forces and some of those lateral forces from affecting the array. And so that's kind of the trade-off that you're making, is more weight means less attachments, more attachments, less weight. And you might end up in a situation where it's a fully attached system. There's some other considerations there if you're thinking of using solar as, say, a pergola roof or something like that, and amenity spaces below, and then you're getting into fire suppression systems. But there's a lot of really creative ways to solve these problems, depending on what's the shape of that solar readiness zone, what's close to it, what's going on. Again, this is where early coordination with a solar contractor really makes sense. So again, I kind of mentioned some high end of the ballast. We could actually go back to the last slide. I did want to point out one thing there, which is, the ballasted weight can be on the high end. You see some typical numbers there. And again, we can get creative. The picture below is an array that we did for Harborview Medical Center, where it's a fully attached system where we coordinated very closely with the roofer during a roofing replacement to add some sleepers in place, make sure that the waterproofing was great. We were able to get great density on a fully attached system. Let's go to that next one. Okay, so solar panels are not the only piece of equipment involved. There's an inverter, which is converting the DC electricity from the panels to the AC electricity used in the buildings. Inverters can be single phase or 3-phase. I apologize for the background noise. It is lunchtime at school, and I've got a couple of kids in the house. So the inverter, there's 2 different kinds of inverter technology you should know about. One's called a microinverter, the other is central inverter. Microinverters can be a great application. They're just located beneath each module, so you're really minimizing wall space that you might need. Our preference is actually for central inverters for a number of different reasons, and a lot of times cost is the largest one. If you're using central inverters, they can be mounted on the roof near the array. They might be on, a doghouse or penthouse or elevator shaft wall or something like that. Energy code projects, we see anywhere from 1 to 3 different inverters used. And then you have some additional equipment there, right, where we need to combine the output of multiple inverters or multiple streams of microinverters into a single circuit. And so we'll use, it's essentially a sub panel, but it's dedicated for solar combiners or combining solar outputs, as well as a disconnect. And if you're in the downtown ring network, the utility is going to require a network relay to make sure that the solar does not backfeed into the ring network, creating some equipment issues. And so that can be an additional cost as well. Again, this can be located outside, preferably not in southern, direct south-facing sun. That's not great for power electronics, but on an east or north-facing wall is great. Or it can be located down in a garage near an electrical room. Space in electrical rooms is often limited, but again, with a little coordination and pre-planning, the equipment can live there as well. Let's go on to the next slide.
Okay, so in Seattle, you've got to place 1/4 of a watt of solar on your roof for every square foot of conditioned space in the building. So does that number sound familiar? The 1/4 of a watt? It's the same amount of solar as you would need for those 3 C406 credits. But in this case, it's a requirement, not an option. There's one exception and a few alternate compliance methods. The exception is that affordable housing is not required to comply. And for those of you who don't have the space or the desire to put solar on your roof, you have the option of gifting all or part of it to an affordable housing project. This could come up because some of the taller multifamily uses their whole roof for recreational stuff. That's fine. We got a place for that solar to go. If you're wondering how big this requirement is, the answer is not very big. 2-story building, that's just 3.5% of your roof. And for a 20-story building, it's 36% of your roof. So, Reeve, cost.
Sure, yeah. And I'll just note on that, on plans when you're getting into that sizing, a good rough rule of thumb is 1,000 watts of panels is going to be in about 100 square feet of roof. That's a really rough rule of thumb, but it's one that has stood the test of time even as modules are getting more efficient. So yeah, suggestions to reduce cost: coordinate early, coordinate often. Definitely creating a solar-only space on the roof. If you're working with a contractor, I mean, this is one of the things that we often find showing up on a job site after the fact is that plumbing contractor, HVAC contractor, somebody saw that the vents were supposed to go somewhere and said, well, the easiest path for me to get to the roof is to go straight up, and now we have a vent in the middle of our array. Even having a vent encroaching 6 or 8 inches into the array space can cause some real issues, and making sure that we can fit the array there, that increases labor and on and on. So even within the solar only space, looking for drains, crickets, sleepers, making sure that other things stay clear of that space. Yeah, and again, it comes to coordination. So, talking about a tall roof and making sure that the roofer is involved to understand what kind of attachments may need to be in place, understand that really an engineering report is ultimately responsible for telling you how many attachments there are going to be, or how much ballast there is going to be. those aren't things where we can have rough rules of thumb. It's going to depend on each building, each location, what their exposure is, how far we are back from the roof, and on and on. One of the other things is going to be, again, the size of the array. The larger we go, the cheaper per unit it's going to be, which means that the greater the financial benefit is going to be for the building owner and operator. Hoisting to a large roof and coordinating when the installation is happening is going to be a very important piece of cost. If you're not familiar with with crane costs, they can be quite significant. So if we can come in and coordinate hoisting to get our panels and especially the ballast blocks to the roof while a tower crane or boom crane is still on site, we're looking at just moving a couple pallets of material up to the roof at once. If those cranes are gone and we're having to haul those panels up through a stairwell and try and fit them, sometimes they will fit through an access hatch, sometimes they will not. Things do start to get more expensive when we're duplicating scope and bringing our own hoisting, our own crane to site in order to move things. Solar labor is not cheap, so the alternative of hauling it up by hand, that can add some significant cost as well. Again, unique ways to address limited space is going through various attachment systems to bring panel systems up off the roof. One of the things that we see frequently in the Portland market are steel structures that exist over mechanical spaces to elevate the panels, but not insanely high, but they are mounted to a firm structure that allows some coordination with other equipment beneath. If there are any kitchen hoods or exhaust vents, we want to make sure that those stay away from the panels so you're not spewing grease and dust across the glass because, well, solar panels want sunlight and they want clean sunlight. Typically, you're going to want to avoid a north-facing roof. You can see on these panels, we do tilt them up. So if it's a slight north slope on like a flat roof, we're not talking about anything significant. We can overcome that with a tilt. But if you're looking at some kind of shed roof or something like that, we really do want to see a south-facing roof. And in Seattle, if south isn't available, a west-facing roof is going to be your second best. You can always do east-facing as well. It's just not. Typically, especially in the downtown area, you're going to have morning fog and clouds. And I think we can go to the next slide.
Okay, and I think that's it. And Reeves, thank you very much. I should tell everybody that I've been shamelessly using A&R Solar for advice about how the real world works on these issues as we develop code. Thanks for all that help. So we're back to lighting for a minute. You got to commission your lighting controls if the project is over 20 kilowatts of lighting, and more than 10 of that is controlled by daylight sensors or aux sensors. With current lighting, 20 kilowatts would be what, 30,000 square feet of area. So, as you probably noticed already, just about every place has aux sensors or daylight sensors, or maybe both. So this really needs somebody who knows what they're doing to do the commissioning. And note that while you're at it, you have to commission the control receptacles to verify that they actually turn on and off when they're supposed to turn on and off. Shaun, commissioning.
So just a quick note here. The lighting industry has long been guilty of imprecise language. When we talk about starting up a lighting control system, and I'm as guilty as anyone, we've long talked about commissioning the system. We're gonna program it, so we're gonna commission it. This is not what commissioning is. Commissioning is a third-party verification process. Those of you who are sort of in the HVAC world are long familiar with the notion of commissioning. Lighting, not so much. IES has DG 2911, which is the design guide for commissioning, process applied, and lighting control systems. Fantastic little document that gives you a step-by-step flow chart of how you commission these things, why you commission them, and all that kind of good stuff. But they are not the same as programming. If you go to the next one. ultimately, this sort of cycles back to what I was saying earlier. You need to do a sequence of operations, right? Somebody is going to need to program all of these kinds of things in your control system. And just as importantly, when you're talking about commissioning, somebody's going to need to verify them. So this sequence of operations need to be available for both the programmer and the third-party commissioning agent. Next one. And this has nothing to do with codes, but please, 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 always commission your occupants. Tell them what to expect from lighting controls. That will really go far in improving acceptance, making users happier, and also for contractors out there, reducing any potential callbacks when people don't understand why lights are dimming automatically, for example. Okay, and that's it. Next up.
All right, so I wanted to touch on metering, and I wanted to emphasize that it's not the meters that I care about, it's the display that the building manager can see every morning. Seattle rules haven't really changed much, but the state code now requires all 5 of those sub-metering categories instead of just HVAC and hot water like they used to. So whenever you've got a tenant that takes up a whole floor or several floors in a multi-tenant building, that tenant gets its own dashboard. And the idea here is that the landlord can't typically do much about tenant energy use, but the tenants might want to track this themselves. I certainly know that at last firm I worked at, they would have had a whole committee walking around with clipboards, checking to see if you had things plugged into the right thing. And as we're closing in on the end of the seminar, I wanted to spend a little time on existing buildings. And here's the ground rules. Generally speaking, anything you don't touch can stay like that pretty much forever, but any new stuff you put in has to meet current code. Now, if it's a substantial alteration, which is usually like a complete remodel project or something, we treat it almost like a new building. And the same goes if you change the occupancy from factory or warehouse into something more polite, or if you had a heating or cooling to a space that didn't have it before. We're aware that this adds a lot of money to a project, but the idea is that this only happens to a building once every 30 or 40 years, and the very least expensive moment in a building's life to do an upgrade like this is when you've already got the contractor's trailer on site and you've moved out most of the occupants and you're doing other serious work. Now, for lighting alterations, we've got a 3-stage approach to keep it proportionate to the scale of the job. So in the first stage, if you replace more than 20% of the fixtures in a space, you have to bring the lighting power in that space down to code. And that usually means replace everything with LEDs, but your client was going to do that anyway. Now, if you're adding new fixtures or if you're rewiring or recircuiting the existing ones, you can, you've got to add all the controls that apply to that space. So manual switches, daylight controls, aux sensors, the works. And finally, if you're moving or replacing the main lighting panel for a floor, you've got to add the automatic time switch system. So with these last 2 categories of upgrades, I'm wondering if LLC fixtures might end up being the more economical path to do it to avoid installing all that switch wiring. Shaun.
Yeah, and that's actually a great sort of thing. You know, there are a lot of ways to think about retrofits, but when you're doing them, you know, you've really got to think about 2 different things, right? You've got to think about your light fixtures, but you've also got to think about your controls. So you're certainly going to want to review the existing lighting. Is the existing lighting overkill, right? Do you have more light than you need? Do you need to right size it? If you go ahead and redesign, that's great. If you replace, that's also great. If possible, keep as much existing wiring as you can. And consider using LLCs first, wherever you can, because there's so much less installed wiring that you have to deal with. And if you're using LLC or network lighting controls, or likely a combination of both, wireless systems really save an enormous amount of labor, and you will have the ability in both of those cases to work with utility incentive programs for retrofits. I know that you really want to take a look at some of these things. So, and next.
So, control receptacles in alterations, just keep in mind that you only have to provide 50% of the new outlets as controlled outlets, not the total number in the space. And finally, we got to we've got some rules for adding metering to existing buildings. If you replace all or most of your HVAC system, you'll need to meter that incoming energy at the building and at least sub-meter the HVAC and provide a display. If you're replacing just a couple of equipment pieces, you put in just a local totalizing meter for electrical use on each one of those pieces of equipment. Finally, if you're rewiring the whole building, you need to follow all the metering rules. Shaun, did you have any advice about keeping costs down when you add these meters?
I'm afraid not.
Okay. So undoubtedly, some of this that we've been discussing for the last couple hours sounds pretty hard to do. We've got plenty of extremely high performing examples of buildings here in Seattle and elsewhere around the country. I've often quoted Mr. Frankel here, that which exists must be possible. Shaun, take us home.
And I'll just quote Louis Kahn. Whether you're talking about designing, redesigning an entire college campus somewhere or one small floor plate, the structure is a design in light. So remember that you are ultimately designing a space or installing a space or implementing a space for people with eyes to live, work, play, do whatever in. We want to minimize the energy use possible. We want to maximize the flexibility of the space, but ultimately at the end of the day, we're all working for people, right? So there you go with that.
Before we wrap up, did you want to do another couple of questions?
I'm going to say, why don't we hold the questions till the end, and okay. We're likely to spend a little bit of overtime with the questions. We'll go from there. How about that? Okay,
sounds good. Please do get in touch with either of us if you've got further questions. It was great being here. Armando, are you on the line?
No, it's me. So the we will go ahead and entertain questions. Don't get me wrong. We are going to go ahead and do that. But we're going to switch gears briefly for just a moment. So a few words with Customer Care Energy Solutions. I'm going to introduce the two folks from City Light that are going to be joining us. Madeline Kostick is from the commercial retrofit program, commercial lighting retrofit program, and Julie Banerjee is with the new construction program, both from CCES. Forgive me, it used to be CES. Why don't you guys give a quick introduction of yourselves, and then we'll go ahead and do the poll questions.
Great. I'm Julie, and as Shaun said, I manage our new construction programming, which has a portion of lighting included, and Madeline is responsible for the retrofit side. So we wanted to walk y'all through some of the distinguishing factors that might make your project a retrofit project versus new construction, because it can be confusing.
Yeah, so as you guys may be aware, hopefully are aware, Seattle City Light has funding for energy efficiency projects. And as Shaun mentioned, we do have a $50 bonus for any retrofit projects that include fixtures that are controlled by LLC or NLC. So we just wanted to clarify here from a utility perspective what we consider retrofit and new construction. So basically, if you answer yes to any of these questions, it is a new construction project, and it would go through our new construction program. If you answer no to all of these, it's a retrofit project, and it would be eligible for our retrofit incentives, which include that $50 bonus. And so just wanted to make sure that's very clear, since we've been talking about code here and how the utility sees it from a energy efficiency funding perspective. Do you want to do the poll questions, Julie?
Yeah. And just to add, I think, the other reason it's important for you to know is because the funding amounts are quite different. In new construction, we can pay for energy efficiency savings above the minimum required by code. So that difference doesn't allow for us to support as many controls, for example, because that is covered by the code. So it's really important for you to ask and then see how we can support you with incentives. Great. And so we have a few questions that we want to learn a little bit more about you, the projects that you're thinking about putting forward in this next year, particularly under this code, but then also a couple questions around retrofit projects. So the first question we have for you is if you've actually taken advantage of those incentives we were just talking about for energy efficiency. And the questions that we have is, yeah, I've done that for retrofit projects, yes. Just new construction, yes to both, or no?
So folks, go ahead and click in on your screen if you would be kind enough. We'll give you about another 20 seconds. I feel like I should be doing the Jeopardy.
I know, we definitely need a sound.
All right, we are going to close this out. Thank you for doing that. And so sharing the results.
Yeah. What an opportunity at hand. Hopefully you guys knew that there were incentives available, but if not, we have them displayed on our website, or you can reach out to anyone on this call today from the city, and they can point you to us. Next question.
And I can tell you from the perspective of a design professional, I wish I had known more in private practice about some of the programs that were available. So please take advantage of them.
Fantastic. Again, we mentioned a little bit about how our funding works related to if your project's going to be above that code minimum efficiency that we've talked about. So when you're thinking about the projects you'll be taking under the 2018 Seattle Energy Code, how likely are they going to be above that code minimum efficiency? Not at all likely, not likely, neutral, somewhat likely, or very likely. And this really, questions to this really helps us understand how we can help you. If we're, available to provide incentives above the code and you're thinking of taking projects like that, we can look at how we can support you financially in addition to events like the ones that we're holding today.
All right. And here are our results.
Yeah, and I would say that's probably as expected. We're doing a really great job in code in supporting the efficiencies, and so going above can sometimes be challenging. Thank you all for your responses.
Okay, let me go to the next one. There we go.
And going through the different, code pathways, you have options of how you engage in lighting. So we wanted to talk a little bit about the C406 prescriptive path. And when you're looking at the credits that you're going to be choosing in that pathway, how likely on those projects are you to propose reducing that power allowance by 10% or by 20%? So are you likely to propose both of those options? Are you likely to propose the 10% power reduction, likely to propose the 20%, or probably not either? I'm probably going to move forward with another credit.
All right, just a couple more seconds here.
Great.
There we go.
Fantastic. This is, again, really helpful for us to understand where we can meet you in your code journey, in your building journey, and support you to meet those energy efficiency goals that you have. And I think we have 2 more questions for y'all.
2 more indeed.
Madeline, I'll hand it over to you.
Sure. So this is pretty straightforward. Just curious if you've used network lighting controls in the past, and this can be for either your retrofit projects or your new construction projects. Just thinking of any of your lighting projects in general. And this is luminaire level lighting controls or non-luminaire level lighting controls, network lighting controls.
And while we're waiting for a little bit more of the voting, I will also say those of you who haven't, please feel free to contact me to go through the lab resources, any of those things. I'll be glad to help however I can to smooth your journey. All right.
Woohoo! Good. You guys are the right audience. Okay, that's good to see.
That's very good to see. We definitely want more of that. And the final double jeopardy question.
Yes. So this is, how likely are you to include network lighting controls in your next LED retrofit project? So specifically for those of you that work on retrofits. So if you think back to the, I'm not asking about a new construction project, but just for your retrofit projects, how likely are you to include network lighting controls in that next project?
I'll give you just another few seconds, and there we are.
Great. So that's great to hear. And I just want to make sure, again, to encourage everyone to visit our website to find the information on incentives or reach out to any of us directly if you have trouble finding it. We really want people to be able to take advantage of that $50 bonus to help promote this technology in the retrofit field.
And again, if you have questions, if you're unclear on how some of these things come together, there's a huge amount of resources on the Lighting Design Lab webpage. And I'm also available to help with questions.
I think
do we need
that's
to go
all
to
we
another
have.
slide here?
There we good? All right. Then thank you, Madeline. Thank you, Julie, for joining us and giving us all that information. Duane, shall we pivot and start asking questions? Or okay, this is one good thing before you do the questions, just to let everybody know. The next class coming up is going to be next Tuesday, somewhat predictably, 10 to noon. And it is going to feature Duane once again, giving us fantastic information. In this particular case about water heating. He alluded to some of that stuff at the beginning of the discussion with respect to the electrical portion, and we'll be having more next week, so that will be fantastic. And of course, the video and all will be available at lightingdesignlab.com. It will probably take a week or so. Also, I gave everybody, hopefully in the chat, you'll see these. I went ahead and put in all of the links, the URLs that you can have for downloading the various studies and things to which I alluded. So with that, you can contact both of us here. And before we go to the end, it is 12 o'clock now. Duane, can you stay on for a little bit?
I'm happy to stay with anyone who's geeky enough to want to keep asking questions, so please do.
Okay. Those of you who need to leave, please feel free to do so. Thank you, thank you, thank you. I hope this has been helpful for you. Please take the online survey when you exit. In particular, if there are topics that would be helpful for you to have more training or more information on, that is really helpful for us to be able to go through and develop our class curricula. We really appreciate it. Those of you who have questions, we're going to cycle back through the questions that have already been asked here, and we'll do what we can to meet them. So let me start with there was one here about what is the life expectancy of equipment? This is solar. What is the average life expectancy per solar panel in today's terms, yep, that's it. Okay.
Sure, yeah. So the solar panels themselves typically have a 25-year warranty. There are some that just have a 10 or 12-year material warranty on them. Typically, any defects we see show up within the first 6 months to a year, well within the warranty period. Some panels, I should clarify, there's like 3 different levels of warranties on panels. You have the material warranty, and then you also have the power warranty. So over time, they do degrade a little bit on their output, which we can model. And some of those are the longer 25 to 30-year warranties, but we are seeing more and more material warranties match that same timeline. Lifetime-wise, we're expecting panels to have effective lifetimes of 30 to 40 years, if not longer. The very first solar panels ever built are still operational today, many of them. So it's a long life. Inverters will typically have a 10-year warranty, and we model out in our financial modeling like a 15-year replacement time, because they are power electronics and go through quite a bit of cycling.
Okay, thank you very much. There's a question here regarding schools. Can you speak to meeting the WAC requirements for the illuminance in classrooms, given that some health inspectors are very literal in their approach to the 30-foot candle minimum required in these spaces? Duane, do you have anything to say to that, or shall I respond to that?
I think you're the pro.
Okay. So for those who are not familiar, there is a, this kind of comes back to precision in language. Normally speaking, when we talk about lighting levels or target light levels, requisite light levels, whatever they happen to be, we're usually talking about average light levels, because that's the only reasonable way to normally talk about lighting, because lighting is quite variable. The WAC, unfortunately, says 30-foot candles minimum are required in classrooms. Now, that's an unfortunate bit of language, but most of the time it's assumed that, and some of you who do more schools certainly than I do will probably have had other sort of experiences. But what the discussions I've had with folks from OSPI, Office of Superintendent of Public Instruction, particularly those folks who are dealing with the High Performance Schools Initiative, have been pretty clear that what their intention is not that it's 30-foot candles minimum, that it's 30-foot candles on work surfaces, basically. So what I mean by that is, yes, the questioner probably has encountered folks who have gone over into a dark corner that nobody's ever going to do anything with and self-shouted with a light meter and said, there's only 22-foot candles here. But the key thing is that on desks and on work surfaces, it's supposed to be 30. I don't have a great answer for how to avoid that, because that is potentially a big energy waster for having to overlight the rest of the classroom in order to make sure that the dark corners are 30-foot candles. Okay, what do we have here? Perry notes, time delay to match current lamp technology. So this is facility maintenance staff need to be kept informed of these rules of thumb. So this alludes back to the discussion that I had said, that the reason that we used to set occupancy sensors out at 30 minutes rather than shorter timeouts didn't have to do with making sure that we didn't have false triggers. It was entirely to make sure that we didn't reduce the lamp life of fluorescent lamps, because the number of times you switch them off and on matters. The number of times you switch an LED off and on doesn't matter. So anybody who is working with any system that has LEDs, we're no longer concerned about lamp life with respect to switching anyway. Okay, there's a question. LLC is great, but we recently did a tenant improvement in the building that had it, and the building had been sitting unoccupied for a couple of years, and no one knew the passwords to get into the controls front end. And the controls quickly are becoming a something. It kind of cuts off after that. So this is actually an issue with respect to any building system, that whether we're talking about LLCs or wired lighting controls or frankly HVAC systems with BACnet, if you have any kind of password protection for use or reprogramming, any of those things, that's going to be an issue with any system. It's kind of the same ballpark as cybersecurity issues. I frequently hear about cybersecurity issues with respect to wireless lighting controls or LLC, and it's true, there are issues, and they're the exact same issues that you have with wired or wireless HVAC systems or wired or wireless scheduling systems, all of those things.
Or with Bitcoin.
Or I'm going to let that go. Someone here says there is a white paper that says UV is not effective for viruses like COVID. I would be interested in seeing that white paper because it is the exact opposite of what basically the entire industry is saying. So I have not seen a white paper that says UV is not effective for viruses like COVID, and I'm not sure that I believe that's true. Legacy Pratt's not clear. I don't know what that is. Does color temperature impact the endocrine system? Which is more impact? So this is a light and health question. Does color temperature impact the endocrine system? Which is more impactful, controls or color temp? So the endocrine system, your sleep-wake cycle, your kind of light and health, we now understand that light exposure, all light exposure has some impact on our physiology. There are a handful of key variables that we pay attention to. One of them is not so much color temperature, to be technical, but the spectral power distribution, what wavelengths are included within the white light that we see. So spectral power distribution, intensity of light, directionality of light, time of exposure, historicity, meaning how much light you're exposed to on a day-to-day basis, sort of as an aggregate. There are a lot of different things. It's actually fairly complicated. Again, I would say take a look at the Lighting Design Lab classes. I talk about this at some length in the Light and Human Health class that is recorded there. Does the NLC option still require individual fixture control?
No.
Except in the greater than 5,000 square foot office. Is that not true? Doesn't in the greater than 5,000 square foot office doesn't require individual addressable controls?
I think we took that up. We're talking about where yeah, I think that each individual fixture requires it, but there was an older code requirement that required, like, I think everybody's desk to be able to adjust their light above it or something, and that really that really never worked.
So the short answer then is individual personal control is not necessary, but we still do want to have each individual luminaire be its own control zone in that greater than 5,000 square foot office, right? Okay.
Now we did say that for daylight control you can string several together, because people were a little irritated by having a string of lights along a window wall and having some higher and lower. So you can do a certain amount of combining.
And that's a good programming practice, by the way, to go ahead and do that in general. And that is for most networked lighting control systems, LLC systems, that is a relatively simple programming issue. Another financial positive, area coverage per luminaire can be significantly more with today's LED. Both total light output and light distribution can be more per fixture. Okay, that's more of a statement. Okay, there's a general question here. I'm not going to read the whole thing from Paul. I hope you're still with us. So the question basically is, you're talking about networked and LLC light fixtures. The question is, have we reviewed the efficiencies of PoE, power over Ethernet lighting versus line voltage? That's a complicated topic. There are a lot of different, for those who don't know PoE lighting, essentially we take what are effectively Ethernet switchers and run Cat5, Cat6 cables to the light fixtures that delivers both power and data. So there are a number of different ways, a number of permutations that can be in effect in these kinds of systems. So anybody who's interested in PoE systems, Armando Berdil, who works with the lab, also did a class on PoE. And you can find that information on the, again, as a recording on the Lighting Design Lab webpage. I'm not trying to not answer your question. I am suggesting that the answer is longer than we have for today. Oh, here's a good one. Is redundant wiring required for the combination controlled, non-controlled receptacles described? So in other words, do we need to have redundant wiring if we're going to have split receptacles?
And what I heard from electrical engineers is that, yes, you need this little extra switch wire to make that go, and that it was so much less confused. Two big advantages. One is it was less confusing to everybody because every outlet was the same. But the other was it got us past the worry about people daisy chaining long extension cords from a non-controlled outlet out to where they needed something. And so this way, everything's got a controlled outlet, everything's got a non-controlled outlet, and there's no extension cord required. And
I'll amplify on that just a little bit. That so yes, in most cases you would need, as Duane suggested, an extra hot wire. If you are doing a retrofit, that can be a little bit challenging. So there are several manufacturers that offer smart receptacles that are essentially a part of a network lighting control system. That one of the receptacles is controlled, one of the receptacles is uncontrolled. It has a radio transceiver receiver right in it, so that it effectively functions like it's a light fixture. So you can just replace receptacles one for one, program them into the system, and of course you're going to pay more upfront for the receptacle itself, but hopefully you'll more than recoup that with the lack of rewiring. Okay, let's see. Here's a non-lighting question. For the gas stoves, require a 240 volt outlet requirement. Does the electrical service capacity to the building have to be sized to actually power all the stoves? Same question for the individual unit panels.
And the answer is yes. We really wanted to make this so that if in an apartment building somebody, and I don't know if anybody ever does gas stoves in apartment buildings anymore, but if they did, since we're going for this carbon neutral Seattle and the time is getting short, we do require that be ready, that you can pull out the gas stove and plug in the electric and have nothing to do but go over to the breaker and switch on that circuit.
Even at my home, I can say we this fall switched out from gas heat to a heat pump and love it. Really looking forward to switching our, when we redo our kitchen, to going to induction. It's going to be great. Has Seattle DC&I put together a solar guide for design development industry?
We do have we have a series of what's called tips that are online at the SDCI website, and a couple of them do involve solar. Those will, of course, be getting rewritten over the next several weeks for our new code requirements.
Here is a thanks, Duane, for including Reese. Excellent overview on solar. So fantastic. How long does the battery in a wireless wall control typically last? So we've been talking about wireless lighting controls kind of off and on throughout. Most of the time, for most manufacturers, the industry has really pushed towards wireless everything. wireless occupancy sensors, wireless daylight sensors, wireless wall switches, so that you don't have to wind up, bringing, say, a switch leg or even low voltage wire down a finished wall and into the wall. Most of the time, most manufacturers are advertising a 10-year battery life, and that actually seems to be accurate. So we had a recent thing at the Lighting Design Lab a year and a half ago, when one of my colleagues pointed out that the wireless wall switch in our conference room wasn't working anymore, and was a little bit critical of the notion. Oh my goodness, they're supposed to last 10 years. Well, how long has the lab been at this new facility in Soto? Oh wait, it's been about 10 years. So it actually was anecdotal, but really sort of tended to really highlight that that's true. So 10 years is typically the general idea. If it helps, I know some people don't like the notion of every 10 years replacing all the batteries in their facility. I did a study with a couple of contractors with respect to that, and the sort of time frame that it would take, the difference between the upfront cost of running a either low voltage or switch leg down a wall versus every 10 years replacing the batteries in your system. The break-even point for the when you would recoup extra cost for having done the upfront of the labor of the wall was 40 years. So go with the wireless, it's a better choice. Does LDL have any plans for classes addressing code required lighting renovations and remodels? We actually do have classes with retrofits and remodels, things like that. They're not specific to code requirements as we have here today, but we do actually address code requirements in them.
Shaun, I would say that sounds like a good topic for another seminar we should put together, is just entirely alterations of various kinds.
Sure, that sounds like a very interesting thing. Another thanks. Thanks for a comprehensive session. The guest presenters were especially valued. As we start putting radios in devices such as the receptacle you just mentioned, have we looked at the parasitic load of the radios, or do we think that the benefit of turning off the load vastly offsets the energy concern of the radios? I will. Okay, so I'm gonna answer this unless you have a comment on that. Most of the communications technologies that we're talking about with respect to these really all wireless building systems in kind of the smart building ecosystem, they're generally using things like Bluetooth Low Energy or Zigbee or similar one of these systems. And between the amount of information that they have to transmit, which is extremely small, and the transmitting requirements, the loads with respect to the transmitters are extremely small. So I wouldn't be terribly concerned about that. I'm sure somebody's got a paper out there about it, but I'm not aware of it. Is there a higher environmental cost to the tens of thousands of batteries being thrown away every 10 years versus hardwired? Well, let's see. So I'm going to answer this by saying the very first distributed lighting control system that I designed years ago was the Amgen Helix campus up at Pier 90. This was a 1.8 million square foot campus. Now it's become the new headquarters for Expedia, and it didn't actually get built out in 1.8 million square feet because some of the buildings never got built because Immunex was purchased by Amgen. The distributed lighting control system was a big deal at the time because it at that time you typically had relay panels or dimming panels in closets. So the electrical contractor actually calculated the miles of pipe and wire that I saved by going to a distributed control system. I would make the same argument with respect to wired versus wireless. Yes, you have a number of small lithium batteries that get changed out every 10 years versus the large amount of embodied carbon that you're going to have with respect to all of the pipe and wire that you're going to be having to have within the space. So I don't know if anybody has done any true exhaustive studies on that, but I'm going to suggest that a project that I did over in Abu Dhabi some years ago that never got built, the decarbonization, they had a big decarbonization strategy with respect to that, and wireless controls were a big part of that. I don't remember what the ultimate sort of break point was there, but I suspect that it probably is still more environmentally sensitive to use the batteries. Last one here. Thanks, Duane, on the idea of presenting a class on the existing buildings. A lot of questions arise on our existing building projects, on what level of renovation triggers what level of code upgrades. Yeah, I think that would be a great class, point counterpoint back and forth between us again. I think we should probably put something like that together. Paul, you're welcome. Paul says thanks. And Paul, by the way, if you would like to talk more about, in particular, that battery stuff, go ahead and ping me at shaun.darragh@seattle.gov, or you can find me through the Lighting Design Lab webpage. I'll be glad to talk more in depth, or anybody else with anything else to do with lighting or lighting controls. Any other questions for the, wow, almost 40 of you have actually stayed. This is impressive.
You're troopers, yeah.
Yeah, right. We're both here. You've got us both here. Any other questions? I'm going to call it once, going twice. Duane, any last words?
We are easy to find, and please do find us.
Yeah, and you know, we're both obviously very committed to this kind of stuff. I hope that comes through. So anything that we can do to help with pushing any of this stuff together, we're glad to do it. And last question, video of today's presentation available? Yes, the video will be available on the Lighting Design Lab webpage. It'll probably take a week, maybe two, but if you go to lightingdesignlab.com, the education tab, you'll find video of this class and basically all of the other classes that we have done virtually since the world came to a halt last March. So, all right, with that, well then I am going to say, those of you who are still with us, please remember to fill out the very, very, very brief survey at the end of the class so that we can know what we did well, how we can do things better, and what other things you would like to hear from us. And with that, Duane, thank you very much for putting all of this together, and I think it's been a great session. So.
It's been great. Thank you all.
See you all. You all have a great day.